Welcome back, everybody. So, as a reminder, your exam is due on Friday. Your exam 2, you have 3 attempts at it. So if you haven't taken it yet, please do so. So you have time to digest it and ask me questions on anything that you missed and or correct any easy typos to fix. Remember, you have 3 attempts. So the best best score is the one that's kept. Yada, yada, yada. We've talked about it a bunch of times at this point. So we're going to be starting a new chapter. So this material, we're not going to get through all of it today. So I need to adjust the due date on 3.2's homework assignment. 3.1 will still be due this Sunday, but 3.2, we don't have all the information needed yet. So I'll extend the due date until next Sunday. But this material is not covered on exam 2. So this is new material that will be on the next exam. So starting with section 3.2, which is on averages. So we're starting a unit called that's on statistics. And my least favorite area of mathematics. I do not like statistics because they're closely related to probability. And probability is weird to me. We'll talk about it later on, but have you guys ever heard of the Monty Hall problem? You have 3 doors. Behind one door is a sheep, behind the other door is a sheep, and behind the other door is a car. And if you correctly guess the car door, you win it. And so what happens, the way the game is played is you have 1, 2, or 3. You pick a door. So if you pick 2, the game show host opens a door that has a sheep. So if you picked 2, they would open up door 1. And they'd say, do you want to change your answer? Do you want to stay with door number 2, or do you want to pick door number 3? If you had picked 3, they would have opened up either door 1 or door 2. It wouldn't matter. And they would say, do you want to stay with your choice? And you would think that it doesn't matter, right? You would think that it wouldn't matter. You would always win. Like by them showing you one of the doors that you didn't pick, nothing would change. But in fact, it does. It does actually change the odds. And so it ends up being that you have a higher chance if you switch than if you stay, which is super weird. And so that's one of the reasons why I do not like probability and therefore do not like statistics, because they're closely related. Another reason I don't like statistics is for what we'll talk about soon. But to talk about averages, we needed to look at a data set to kind of figure these things out. So we have a data set that we're going to be using. In case you don't know, when you see a curly brace, in mathematics, that means a set, a collection of elements. So the data set is 15, 32, 15, 42, 100, and 27. Now, you probably have heard of these things before. If so, awesome. If not, no big deal. We'll just talk about them. The first type of average that we see is what most people mean when they say average, which is the mean. The mean is where you add up all the numbers of the data set and divide by the total number of entries. So you take all the numbers that are there, you add them all up, and you divide by the total number of entries.
All the numbers or add up all the numbers?
Should be add up all the numbers. Dope. Add up all the numbers. Thank you for catching that. That's the second time I wrote 4 FOR instead of FOUR for my classes earlier today. And I'm just missing one letter, that's 75% right there. I'll take a C. You know, C's get degrees, as they say. So, in our example, the mean would be taking all those numbers, 15 plus 32 plus 15 plus 42 plus 100 plus 27, all divided by the number of data values, which there are 1, 2, 3, 4, 5, 6. 6 data values, so we're going to divide by 6. If you add up all the numbers in the numerator, you get 231. And divide that by 6, which gives you 38.5. So that is the mean of this data set. That is the mean average. And so this is, once again, this is what most people mean when they have, pun intended. This is what most people mean when they say average. So they say the average, most of the time, it's generally assumed that they're talking about the mean average. Though I would like it if in our world we now started quantifying which average we're talking about. And you'll see why in a little while. But because averages can be used to skew data. In particular, so I want to make this note about the mean. It's a very, very important note. The mean is heavily affected or heavily influenced by outliers in the data set. So I want to show you what I mean by that. So let's just say for whatever reason, I give a 200-point exam. I give a 200-point exam. And you don't need to write this down because this is just a small example. Let's say it's a 200-point exam. And I have 5 students. 2 get zeros, 1 gets a 10, 1 gets a 15, and 1 person gets a perfect score.
So everyone stuck is that person.
Yes, everyone else failed miserably except for that 1 person. The mean would be, so 225 divided by 5 entries. The mean is a 45%, or 45 out of 200, which not a good score, right? 45 out of 100, that's less than 25%, but that's significantly higher than all but one of the people. That's skewing the data heavily. So that 200 ended up really screwing things up. That 1 person really screwed over the curve. And so that's the situation. Everyone was averaging about a 10, right? Like the average of the first 4 people is a 4 divided by 25 divided by 4. It's a 6 and a 6 and a quarter. So this number is not reflective of that class as a whole. So you might be like, okay, I guess that's not terrible or whatever, until you realize if you looked at the actual scores that everyone was failing miserably except for that 1 student. And that would be a situation where you want to reevaluate your score and try and figure out what was wrong. So point being is that the mean is heavily affected by outliers on both sides. So if, like we're talking about median household income, and you take several districts that have lower income areas, and then you take one district that's like a super rich area. I remember where I lived, we called a place called $1 Million Hill because every house was multiple millions of dollars. It was a very pretty area, of course. But like you take that and combine it with all these other low income areas, and you could say the average median household income is like $75,000 when the other class, like when the actual situation is far worse. So that is why the mean is not a great choice, in my opinion, for this. What do we do instead then? Well, we talk about the next one, which is the median. The median is the quote unquote middle number of the data set and so it would be nice if you could just find the middle number and call it good, like of any data set. But sadly, there's a caveat here. It's the middle number of the data set when when the entries are arranged from smallest to largest. Now here's a little issue though. What if your data set has an even number of numbers, an even number of entries? Then you have the equal number on both sides of it. There's no middle number. So if that happens, if two data values are in the middle, we add them and divide by 2 to get the average, to get the median. The middle number of the data set when they're arranged from smallest to largest. If there are two values in the middle, then you add them up and you find the average of those two numbers, i.e. you add them up and divide by 2. There's a little baby average. So in our example, so everyone's done writing. You looked at our data set from the very, very beginning. Our data set is not arranged in order. If I had it in my perfect world, I would make sure that they were always lined up from smallest to largest. But sadly, this is not my world. This is my son's world. It's management. He's management. I'm just an employee. I love making that joke with my wife. It's like, why is there a mound of flour in the kitchen? Don't ask me, ask management. It's a management decision right there. But anyways, so sadly, there's going to be problems in your homework that have these things disorganized. So they won't be in a nice format. So I just want to give us a little bit of practice with that. So in this example, first reorganized, first reorder. So we had 15, 32, 15, 42, 127. And so the way I usually do it is I keep looking for the smallest number. It's like I work systematically. So I start with the first number that I see, and I see 15. Is the next number smaller than that? No. So the smallest number right now is 15. Look at it. It's the same number. So 15 is still the smallest. That's larger. That's larger. That's larger. So 15 is the smallest number, and it occurs twice. So 15, then 15, then 27, then 32, then 42, and then 100. So, and I would always recommend when you do this, just because you're going to be looking at a computer screen, then back down at your notes, then back up the computer screen, then back down at your notes, or your work when you're doing this. it's always best to count how many data values you have and make sure that the same number. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Good. I know I did it right. And so this is the old-fashioned tried and true way of finding the median. So you just kind of work your way inwards. Take one off from each side, then another one, and then this would be your median. So 2 data values in the middle. So the median is going to be the average of those two numbers, the average of those two middle numbers. So 27 plus 32 divided by 2, which ends up being 29.5. Now, that wasn't too bad, but that's only because we had 6 data values. What if the data set has 15? What is that? What if it has 32 data values? Then it becomes a little more tedious. Like you'd have to go one in, then another one, then another one. And if there was 32 data values, you'd have to do that 16 times. And that's not very feasible. Like that's not very, as the kids say, that's not very cash money, right? Right? That's what you kids say.
Not good.
That's not cool for school. That's not awesome possum, right? So here's a way to find the median in a faster way. Granted, it's going to look weird at first. I'm gonna preface this and say we're gonna use a little bit of math terminology to do this one. How to find median quickly. Step 1. When you're finding the median, you want to find out how many data values there are. Not find out, sorry. Take the total number of data entries and divide by 2. And the reason why I'm going to divide by 2 is that's going to, like, if I take the total number of data values and I divide by 2, I'm going to find half of the half the amount of data values. So when you divide by 2, there's either 2 options, depending on whether the number of entries is even or odd. You'll either get a whole number or a whole number 0.5. So you will either get a whole number, which we'll call n, or a decimal number, n.5. I know that looks weird. That's using a little bit of math lingo here, but so you'll either get a number n or a number n.5. So for example, if you divide 8 divided by 2, so if you have 8 data entries, divide that by 2, you get 4. You get the whole entry, a whole number 4. If you add 9 entries, you get 4.5. If you have 11 entries, you get 5.5. 13 entries, you get 6.5, and so on and so forth. So it all depends on whether you have an even number or an odd number. Step 2. And this is broken up into 2 parts. If you get the whole number n, then you have 2 middle numbers, And the median will be from the nth and n plus 1th term. Now, don't worry, we're going to go over an example of this to explain it. So that's a common thing in mathematics to say like the nth term or the n plus 1th term or the n plus 5th term, whatever. Happens in mathematics all the time. So what do I mean by, like, let you write it down and I'll explain what I mean. So, for example, 8. Or actually, let's look at the previous example. There's 6 data values. 6 divided by 2 is 3. So the 3rd entry and the 4th entry create the median. Look at what we got. The 3rd entry and the 4th entry. 1, 2, 3, 4. We use the 3rd and the 4th entry to find the median. So that's what I mean by the nth and the nth plus 1. Whatever number you get, that number and the next, that entry and the next entry gives you the median. Like add them up, divide by 2. If you get the decimal, n.5, right? So as I said, like 7 divided by 2 is 3.5. 9 divided by 2, 4.5. 102 or 101 divided by 2, 50.5. So if you get the decimal number n.5, then you have a middle number. And your median is the n plus 1th term. I'll let you write that down, and then I'll explain what it means. And we're going to do some examples of this afterwards. You get a decimal number, n.5, then there is a middle number, because if you get a 0.5, that means that you have an odd number of data values. And with an odd number of data values, you can split that up into 2 even groups and 1 left over, right? 3 can be split apart into a 1, and a 1. 5 can be split apart into a 2, and a 1. 101 can be split up into a 50, and a 1. So if you have an odd number of data values, that's when you have a middle term. If you have an even number of data values, that's when you have 2 middle terms. So if there are 100, like let's just like, I'm going to write this down so you can see it, just so we're saying as we go aloud. If you have 13 values, 13 data entries, divide that by 2, you get 6.5. That means the 7th term. So that like n.5 would be 6.5. That means the next number, 7, is your median. If you got 18.5, the 19th entry would be your median. If you got 21.5, 22 would be your median entry, or your median value. So I'm going to give you some examples. Find the median. So A is going to be the data set. All right, let's pick out some numbers from the top of my head, because it doesn't matter what we choose, just as long as they're in order. So let's do 5, 13, 7, 71, 75, 80, 88, 90, 90. And then let's do another one. This time we'll do 100, 102, 102, 113, 121, 140, 147, 150, and 190. This is how you can find the median quickly. And granted, these aren't too large of numbers, like these aren't too large of data sets. It would not be too hard to just work inwards and do it. But what if there were like 13 to like, or what if there were 25 entries? Do you really want to go 12 times inward to find it? So this is the way I would do it. And this will be especially useful when we talk about frequency tables, which we'll probably talk about very briefly at the end of the today. But solution. For part A, the numbers are already arranged in order. Numbers are already arranged in order. There are 8 data entries. So if I take 8 and divide it by 2, I get 4. And that would mean that, so we get a whole number there. So the 4th and 5th give the median. Because with an even number of data set, an even number of data values, data entries, you can completely separate the set into two parts of equal size. So there's no one middle value left out. So because I got a whole number, I know that the 4th and the 5th numbers will give me the median. So 1, 2, 3, 4, and 5. 4 and 5. Those give me the median. So the median is 75 plus 80 divided by 2, which is 77.5. And the next one. There are 9 data values. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 data values. Did you get a haircut? Oh, just wearing a beanie. Okay.
I'm coming about today.
What does that mean?
Well, I had to take my twist down, and I had to put it in a ponytail.
You can put your hair into a ponytail?
Yeah.
Really?
Yeah,
Cool.
it's
You're not feeling it. That's totally fine. Bean looks good. So with this set, there are 9 data values. So I take 9 divided by 2. And I'll get 4.5. That's a decimal number. So that means that the 5th entry gives the median. That's how we do it quickly. So if you get a 0.5 number, then the next number, the next closest number above it is going to be the data entry that gives you your median. So 1, 2, 3, 4, 5. So 121. And just so you know, like this is how much work we've gotten through. We've gotten through about 1.5, 2 pages.
I gotta study. I'm gonna go home.
I can write pretty quickly, I guess. I know. Plus I do like to space things out a lot, I guess.
That's right.
For some of you guys, it might be only like a page or page and a half worth of notes. I don't know. Any questions on how we define the median then? That's the quick way. And that would be especially useful, as I said, with frequency tables, which we'll talk about in a little bit. Okay. So the last type of data average that we know of is the mode. The mode is the number that shows up the most in the data set. i.e., the number with the largest frequency. So I'm using that terminology there. That's the terminology we use in statistics to mean. So I don't mean frequency like in a radio waves or whatever, but I mean frequency like frequent. So how often it occurs. That's what frequency means here in statistics. That's what the mode is. The mode is the fastest one to calculate, in my opinion. So in our example, before I'm going to add a note onto this. If there are two data values, with the same largest frequency, the data set is called bimodal. So let's say like if you have 555 and 666, that would be a situation where you have two numbers with the same frequency, it's the same largest frequency, and that would be bimodal. If there are more than that, there is no mode. So if you have a data set that has more than that, so if there's 555, 666, and 777, that is a situation where you have no mode. I guess you might be able to call it trimodal, but then we're just splitting hairs. So usually just either a mode or a bimodal. And so this is the case. If every number in your data set is unique, right? If it's the data set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It's just all the numbers 1 through 10. Then every number has the largest frequency, and that frequency would be 1. Every number has a frequency of 1. And so since you have more than 2 doing that, it's a no mode set. Any questions on that? So in our example, the data set was, once again, it was 15, 32, 15, 42, 100, and then 27. So the number that shows up the most is 15 with a frequency of 2. You don't need to write the frequency unless it really asks for it, but otherwise you just write what the mode is. That's pretty much always what you're going to do. Any questions on that? A good question would be, what is the mode used for? Because honestly, in my experience, the mode is not really much like an average so much as it is a checking tool to make sure your data set doesn't have any weird stuff going on. So for example, if I gave like a Scantron test, so multiple choice for all the questions, and I saw that everyone was getting like a 77, and then like there was like 20 77s, and then 3 of the ones that are different numbers. That would be a situation where I'd be like, okay, what's going on here? And I'd need further analysis. It could be that maybe there were just like, so if everyone got a 77, then like they missed 13 questions. Maybe those 13 questions were just way too hard and only the A students got them. And like, and none of the B students could get those problems. They were just too hard. That could be a case. It could be that the Scantron machine was messed up. Whatever the case may be, that's a reason why we'd look at that. Another example that I just to say something that was happening in my daily life right now, on my way to school today, I saw this really cool video about a guy teaching Pokemon, teaching AI to play Pokemon. And it was really, really fascinating. Basically, he would give it, and so I have a point to this. He like there were several iterations, and like it was based on a reward system. So the machine was rewarded when it did good things, when it did, and so the good thing being leveling its Pokemon. And so he noticed that several of the renditions stopped at a certain point. So there's a mode of this number here, and it's because they would go to a Poke Center, and then they would deposit a Pokemon. But depositing the Pokemon got rid of the Pokemon and got rid of the levels. So it got a big minus from that. So it started to avoid Pokemon centers because of that. Not that I know what a Pokemon center does, because I've never played before. But point being is, it was a situation where he saw that this mode was happening, that this happened frequently with the AI. So he's decided to go further analysis. That's my main use of the mode. Going back to the median versus the mean situation, the mean average versus the median average. If you go onto Canvas, you'll notice that with any given assignment, you can find the average. Now, what they mean by that, quite literally pun intended, they mean the mean. And so I always caution my students from looking at that, because that number gets heavily skewed by outliers. In particular, sometimes students drop a course or forget to take an exam. Hopefully it's the latter, not the former. Hopefully it's the former, not the latter. But either way, so I have to enter a 0 for them, and that's a very, very, very low score, right? A 0 is the lowest score you can get, and so most students, like, I mean, with my calculus exams that I give and stuff, nobody gets a 0. Like I have given maybe 1 0 on a calculus exam. And so like usually you'll get like some partial credit somewhere. And point being is that those zeros greatly skew the data. So like I had students at one point like complaining to me saying the average was like a 60%. That's really low. You should be upset. I was like, yes, but that's because 4 people didn't take the exam. The actual average was a 75. So, which is right in line with what you kind of want it to be as a teacher. Obviously I want it higher, right? I want all my students to pass, but that's right in line with stuff. So that's a thing where I would say to my students, be careful looking at that. That is the mean average, not the median. The median is a far better indicator of the average score of students. And it's a lot better, it's a lot better average for a lot of things. The mean is very, very good if all of your data is what we call normally distributed. If you've ever seen a normal distribution, it looks like this. It's like the most number of data is in the middle, and then it tapers off on the sides. With a normal distribution, absolutely, average is going to be the best choice. But if your data set looks like this, like that would be an indication that a median might be a better choice. Because there's so much skewed data. Either way, let's look at some examples. Find the mean, median, and mode. Part A is going to be, I'll let you write that down so that we can write these together so you don't have to keep looking back up. You can just hear the number that I'm saying, write it down. Find the mean, median, and mode of the following data sets. We're going to do 2 of them. First one, 10, 33, 50, 50, 76, 81, 50, and 11. Once again, that's 10, 33, 50, 50, 76, 81, 50, 11. And then B, going to be the data set 5, 5, 5, 5. I could keep going. Just 4 5s. 7, 11, 12, 13, and 15. Find all the like 3 different types of averages. So notice that the first set is not in numerical order. So for part A, first reorder. And that's the only reason why I'm doing that is because I have to find the median. Since I'm going to have to find the median, might as well reorganize it. If I don't, if I'm only asked to find the mode or asked to find the mean, why bother? Because the mode and the mean don't really need it to be in order to be calculated, but it doesn't hurt. Maybe it scratches your brain a little bit to put them in order. My son, he's very, very particular about organizing his cars. It's funny being a parent. You can see, okay, that's that part's right, but that's me right there. That's my weird quirk. Because like my mom talks about it all the time when I was a kid. I would organize all my cars from smallest to largest, and so seeing him do that, it's like, of course, that's me. And then he has the independent streak of my wife, where he has to do everything, and so that is an annoying behavior. Great behavior. It's going to work well for him in life. But either way, so we're going to reorder it. So it should be 10, 11, 33, 50, 50, 50, 76, and 81. That's 1, 2, 3, 4, 5, 6, 7, 8. Do I have 8 numbers? 1, 2, 3, 6, 7, 8. Good. I did copy it down correctly. So there are a total of 8 data values, and so we'll write that down. 8 data entries. By the way, you'll notice that I'm saying entries or values to not be confused with the numbers, because I say 8 numbers, that would be like each one of those is a number. So there's that number of numbers. So I'm trying to be very, very particular. So for the mean, we take all of those numbers and add them together. So 10 plus 11 plus 33 plus 50 plus 50 plus 50 plus 76 plus 81, all divided by 8. Do that in our calculator. And by the way, if you're plugging this into your calculator, if you want to do it without calculating the numerator first, you want to do it all in one step, make sure your numerator is in parentheses. If you don't, what it looks like to the calculator is 10 plus 11 plus 33 plus da 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 plus 81, and just this is divided by 8. If you don't put the numerator in parentheses, it assumes that you're only taking care of the 81 and dividing it by 8. So just be aware of that. I don't want that to happen to you guys.
That happens to me, like. I got the answer wrong. Like, then I realized.
It has to do with the calculator. The calculator is only as smart as you make it. And it follows, as I've said before, it follows PEMDAS to a T. So if it doesn't see the parentheses, it doesn't know to add those things up first. There are some calculators that do it properly, but either way, so 50 plus 50 plus 50 plus 76 plus 81. I get 361 divided by 8, which is divided by 8. 45.125, and we're gonna round to 45.1. I didn't mention it, but a lot of these problems say round to the 10th. The nearest 10th. It looks like 451, the decimal's hidden. Let's be on the lookout for what it wants you to round to. It rounds to 2 decimal places, round to 2 decimal places, so on and so forth. So for the median, 8 divided by 2. There's 8 data values. Divide that by 2, you get 4. And that means that the 4th and 5th entries give the median. As I said before up top, if you get a whole number, like this situation, the number that you get and the next number in the sequence will give you the median. So 1, 2, 3, 4, and 5. So the median will be 50 plus 50 divided by 2, or just 50. And if they're the same number, then there's no number in between them. So it just ends up being the same number. But either way. Total aside, just because it happened while I was coming to class today. Has anybody seen a sign for a missing cat, a black and white cat?
I've seen a missing black cat.
The only so I was walking here and I saw one actually right down there, and I wanted, like, I got close enough and it was trusting enough to let me like scratch its neck, and I felt there was a collar. But trying to look at that, then I got the and I don't want to mess with a feral cat, hypothetically a feral cat, or a cat that has rabies. I'd prefer not to get rabies.
It's okay, it's a cat, it's cute, it's worth it.
It is cute. It was a very cute cat,
Was it
but
a black cat?
it was a white cat with like black spots.
Oh, because I saw a black cat on campus after my night class. It was like super dark.
That's not a good sign. That's a bad omen. So if anybody, like, if you see that when you're leaving or whatever, you see a sign for that, they were last seen at the D building. We saw it at the D building. Just hope that cat's okay. Either way, I'm getting sidetracked. Mode. The mode, quickest one to find. What number has the largest frequency? That would be 50 with a frequency of 3. But we don't necessarily need to write that anytime. We don't need to tell what the frequency was. We can just write 50. That's that first set. Part B, I'm going to copy it, put it down there. And say that this one's already in order. Yay. No need to rewrite the set. No need to give us a chance for our for our caveman eyeballs to make a mistake when looking at it. And the other thing is that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. 9 data values, 9 data entries, doesn't matter what you say, but there are 9 of them. That will be useful for both the mean and for the median. So for the mean, just add them up. 5 plus 5 plus 5 plus 5 plus 7 plus 11 plus 12 plus 13 plus 15, all divided by 9. And if you do that, if you plug that in your calculator, you'll get 78 over 9, which is 88.66, on and on forever. So roughly 8.7. Then for the median, because there were 9 data values, 9 divided by 2, that gives me 4.5. So that means so 9 is an odd number. So there is a specific middle number, and it's going to be the number next. So the 5th entry. Fifth entry is the median. So 1, 2, 3, 4, 5. Now with these ones, once again, you can do this by brute force. You can just work your way inwards, but this will be much better if there's more than that. So the median is 7. And last but not least, the mode is equal to 5. That is the number that has the largest frequency with a frequency of 4. Any questions on that? No? Chill. Cool.
This one is confusing that they actually did it.
Good. Good. I mean,
It says a lot.
I'm glad this makes sense. Hopefully the rest of it makes sense too soon. What? There's more. There's more. There's a little more. We got 2 more chapters. And by the way, after this week, at the end of this week, after today's lecture, we are officially halfway through the semester.
Oh, so weird.
Yeah, right? It's been, we got to know each other 8 weeks already,
That's crazy.
right?
It took us that long to finish a crossword.
That's true. That's crazy.
There's no way.
And to be fair, though, it was because that stupid spy on. That was a
Yeah.
That's the only one I did.
dumb one. Next one, I chose a Tuesday. Tuesdays usually have themes that are better, and they're usually a little bit easier. I don't know if I said at the very beginning. The New York Times, the easiest day is Monday, and it gets progressively harder until Sunday or until Saturday. Tuesdays and Thursdays are usually what we call rebus days, and if we get a rebus, we'll talk about it. And then Sunday is variable. Sunday is always a bigger crossword because everyone's home on Sunday. Typically speaking, not necessarily in Vegas, but whatever. Sundays are usually larger, and they can be difficult. They can be easy. They can be medium. Their difficulty is randomized. But so I chose a Tuesday, since we're novices with our crosswords. So, anyways, example. Now let's use the mean. Let's use these things in an actual scenario that could occur. So Phil scored an 87, 88, and a 92 on his last 3 exams. What score is needed for Phil to have a mean average of 90? What will Phil need to get in order to get a 90 on his average? This is something that happens quite often for me, actually. Students will come to me, ask like, what do I need to get in order to get an A in the class or a B in the class? And I have to go out and calculate it for them. Now, granted, with my grading scale, because I weight things differently, like your exams, I think, are worth like 60%, and then the homeworks are worth like 20 or whatever it was. The weighting changes the calculation a little bit, but it still works overall. So, solution. Never seen this question before, but like, let's ask ourselves, what are we trying to find? We're trying to find the score that is needed. Oh, what score on the 4th exam? Sorry. What score on the 4th exam is needed in order for Phil to average a 90? So we need to know the unknown here is the score on the 4th exam. So let's define that as a variable. Let X equal the 4th exam score. Well, what we want is we want the average of the 4 scores to be equal to 90. We want the mean average of the 4 scores to be 90. So we add up all the scores, right? 87 plus 88 plus 92 plus our last score that we don't know, and divide that by 4. We want that to be a mean average of a 90. And so we can solve this in a multitude of ways. My recommendation would be to simplify the numerator a little bit, like add up all those numbers, and you'll get 267 plus X divided by 4 is equal to 90. At which point you can either cross multiply or you can just multiply by 4. If you multiply both sides by 4, remember, you have to do it on both sides. You can't just do it to one. But if you multiply both sides by 4, then on the left side, the multiplication by 4 and the division by 4 cancel out. And we get 267 plus X is equal to 360. And then we got to solve for X. So we've been trying to solve for X, but now we have one last step to do, which would be to subtract 267 from both sides and get that X is equal to a 93. So as long as Phil scores a 93 or above, he will get an average of 90 or better. I think he's got that. He looks like he's been improving each time. 87, then he got a little bit better. 88, he got 92. Going into this next one confident, he's going to get it. Any questions on that? All right, I want to do one of these ones, and I don't like this problem, but it's in your homework, so I wanted to kind of cover it because it's just such a weird problem. So example. The mean score on a set of 25 exams was 79.2. What is the sum of the exam scores? So the reason why I don't like this problem, there's probably a scenario that you could concoct to make this actually usable for something. But like finding out the sum of all my students' exam scores doesn't tell me anything. Like, if I added up all my students' scores, they got 1,000 points. What does that tell me? Nothing. So that's the reason why I don't like this problem. That's my problem with this problem. Is that it's not really useful for anything. It's a good critical thinking problem, but you could have done this much better with a different scenario. I'm sure there's a way to figure out a scenario that works, but this one seems very, very convoluted. So solution. First off, the reason why this problem can be tricky at first is we have to remember, what does the mean mean? What does the mean mean? So the exam mean score is going to equal the sum of all exams divided by the number of exams. Right? Sum of all the exams divided by the number of exams, that would give you the mean score. So in this context, the exam mean score was given. It's 79.2. The number of exams, that's also given. It's 25. But the sum of all the exams, that is the unknown. That is what we're trying to find. That is what we'll call X. But you can use whatever letter you want, or you can leave it as the sum of all exam scores to figure it out. So just rewriting this as a mathematical equation, then we've got 79.2 equals X divided by 25, which we can solve by multiplying both sides by 25, or we can do the cross multiplication trick, however you want to do it. I'll do it by cross multiplication this time. So we cross multiply, and you get that X is equal to, okay, 79.2 times 25, you get 1980. So that's the sum of all the exam scores. Whoop-de-doo. There's not really anything I can do with this information other than just find out that number. This question is mainly meant to make us have a better understanding of what the mean score is as an interpretation. Like in terms of like an abstract concept, instead of here's a specific set of numbers, find the mean. All right. And now to give you an example of why I really think that we should now start, like we should start as a species, being very particular about the type of average we're talking about. So like you'll see this all the time with news headlines, with studies or whatever. They'll say the average this, the average that is this, right? What average are you talking about? It should say the mean average or the median average or the modal average, because of BS like this. This is a fabricated example, right? This is a fabricated company, Jamazon.com, has 5 employees. 4 of the employees make $40,000 a year. And the manager makes $200,000 a year. So the thing is, it's actually more insane than that. This was actually what we back in the day, the usual pay discrepancy between employees and managers and CEOs was usually about 4 times, which was pretty standard. Nowadays it's like 100 times or something like that. It's something obscene. And we have a good old man named Ronald Reagan to thank for that. Good old Ronald Reagan. It's always fun. Like there's even like a TikTok person who just basically goes back to like any problem you see in the United States. It's like you can find a policy that was written during the Reagan era that caused these issues. It's pretty funny. Reagan's an interesting guy. So 4 employees making 40,000, the manager making 200,000 per year. A recent ad put out by Jamazon, so you can tell that it's completely not biased. But a recent ad put out by Jamazon claims that the average salary is $72,000. Why is this disingenuous? Because I guarantee you, if you find the mean of that, so 40,000 plus 40,000 plus 40,000 plus 40,000 plus 200,000, divide that by 5, you get an average, you get a mean average of $72,000. But that's not really representative. Only one person is making above 40 grand. And that's why this is disingenuous. And it's because of the mean. So they're using, and by there I mean the manager, of course, they're using the mean as their average, which is greatly skewed by outliers such as the manager's 200K salary. That's why this is disingenuous. It is using the average that is greatly affected by outliers. You see this all the time in the news, regardless of political association or political leaning side, regardless of what you see it happen everywhere, where people try to bend averages to fit a narrative. And so my request to you is, whenever you see that, stop and ask yourself, what average are they talking about? What average are they using? Are they talking about the mean average, the median average, or the modal average? Because all those ones can imply something a lot different. Like if I only survey Honda and then Nissan, Honda, and then I do Lexus, BMW, Ferrari, and say that the average price of a car is $100,000, that's not really true. It's a mean average when I just cherry pick those choices, but in actuality, it's not. It's much lower than that. So the median would be a better average, because the median of this company, the median salary of this company is 40,000, which is what 80% of the employees make. Now take into example. So this is a fabricated example of a company called Jamazon.com. I think we all know a company that sounds similar to that, and they have a CEO who makes what was his net worth? Jeffrey Bezos, his net worth is over $1 trillion now, right?
Yeah, basically.
So if you were to like putting that number, $1 trillion is an impossibly large number for us. But if you put that in perspective and use his salary, like his net worth, as one of those things, you would be able to say that every Amazon employee probably has over $100,000 for their average salary, which would be greatly skewed and false. It would be a very, not false. It is based in mathematics, but it's based on sketchy mathematics. It's based on statistics, which I don't know, like, if there's anybody who likes Mark Twain, there's a famous quote by him, there are lies, there are damn lies, and then there are statistics, right? And that's because Mark Twain knew about the misrepresentation that you can use statistics for. So, 2 campaigns that I want you guys to try it. Like, I'm trying to make this a thing. So when you're talking about averages, try and make sure you clarify what type of average you're calculating. So like the mean average of this thing is this, or median average. So and like correct people who don't. And the other thing is I want X to make X sound from now on. I say this because like I've been teaching my son the letters of the alphabet, right? And it's like F for fox, Y for yo-yo, X for xylophone. So we should call it a xylophone. It should be called a xylophone. And so I want you guys to say that. So not a Xerox, a Xerox. Please start doing that. Let's change it. Let's be the change we want to see. But what chance does a kid have? It's so confusing. That's so confusing. Okay, anyways, sorry to I'll get off my soapbox. Last thing, yeah, we'll have enough time to talk about what these are frequency tables. And if anybody says like, why are you saying it that way? You say, because it has an X in it, and X makes X sound.
So, but that line is going to say pterodactyls.
I mean, like, yes, that's fine too. Pterodactyls. Pneumonia. I mean, my name is a perfect example of the ridiculousness of our language. I was in kindergarten. My teacher asked me, "It's like, what sound does letter P make?" And I went, "My name starts with P." And it's like, I told my mom, it's like, if it was any other kid, I'd be worried, but not this time. So definition: a frequency table is a data table used to represent large batches of data by breaking them up, by breaking up the values based on their frequency. Based on the frequency of the number. So this isn't going to be useful for like, if you're so there's that whole thing about the average temperature is 98.6. So there's a lot of margins of error. There's a lot of decimal numbers that we can change here. And so in that situation, doing a frequency table wouldn't really make sense. So the average median household, if we didn't want to round to a certain 1,000, then there wouldn't be really a reason to do it. But if there's something like, let's say there's an average, there's a test that we give, or a test that we give to all CSN students, and it's based on whole number points, like 1 through 30. Then we could break everybody down, all 7,000 students on campus, based on a 1 through 2, 3, 4, 5, all the way up to 30. So an example of this. So here's an example of a frequency table versus the corresponding data set. Now, my frequency table is going to be a small one, but this is really supposed to be upscaled to the point where you have like thousands of data values, where it wouldn't make sense to try and write it all down. It would be a complete waste of our time. So a frequency table allows us to do this. By the way, speaking of trying to do things quickly, you can also, and I totally encourage you to do this, you can use Excel for these problems. You can use Excel. Excel is able to calculate mean averages, median averages, and modes by itself. All you need to do is just write down all your entries in new cells. And then on a new cell, press equals, and then I think average for mean, because Microsoft hasn't gotten with the times, but put mean and then highlight all your data values, and it'll spit out the mean. Equals median, highlight your data values, it'll spit out the median. Equals mode, and then highlight your data values, it'll also give you the mode. Feel free to use that. It's a really cool tool. Excel is actually pretty fascinating. There are very, very cool things you can do with Excel, and there's people who do speed runs of Excel. Like, there's weird stuff. People get really, really weird with Excel. So a way a frequency table looks is you've got, oh, whoa, no. You've got a data value. And then we got a line breaking it up and a frequency. And so we'll write 15, and the frequency of that is 2. 31, the frequency of that is 1. 50, that has a frequency of 4. And 86 has a frequency of 2. So I just made these numbers up on the spot. What this means is in your data set, you have 2 15s, you have 1 31, you have 4 50s, and 2 86s. So the corresponding data set is 15, 15, 31, 50, 50, 50, 50. That's 4 50s, right? Yep. And then 86, 86. So that's how a frequency table is used. So yes, this was a total of 9 values, not too hard to just write out as a data set. But what if I add on a 0 to all of these? Now we're talking 90. And I don't want to write down 90 values. This allows us to really condense all of the information down nicely. So that's where we'll leave it for today. So we still have a little more on section 3.2 that we have to do. So the homework for section 3.2 will be extended until next Sunday. We'll pick up next time with the rest of this on how to use frequency tables to find mean, median, and mode. And that'll be it. So please remember to take the exam. It's due on Friday night, 11:59 p.m. Take it now so that you have plenty of time to digest it and let it marinate what you made mistakes on, and then take it again so that you don't have to worry about rushing it at the end. If you have any questions about the exam or anything like that, feel free to email me. Otherwise, you guys have a great weekend, and I'll see you guys on Monday.